Welcome to the session on differentiation, the quotient rule. The objectives for this session are to differentiate functions using the quotient rule. The quotient rule allows us to differentiate the quotient of two functions. So, if y equals u over v, then dy dx equals v times du dx minus u dv dx all over v squared, where u and v are functions of x. The quotient rule in function notation is as follows. If f of x equals g of x over h of x, then f dash of x equals h of x times g dash of x minus g of x times h dash of x all over h of x squared. Now let's have a go at an example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, we are required to find dy dx given that y equals 3x over 5x squared minus 2. So let's solve this. We're going to let u equal 3x, since it's the numerator, and v equal 5x squared minus 2, since this is the denominator. So we have du dx equals 3, we've simply differentiated 3x, and dv dx equals 10x, we have of course differentiated v equals 5x squared minus 2. We will now plug in these expressions into the quotient rule. So we have dy dx equals v, which is 5x squared minus 2, times du dx, which is 3, minus u, which is 3x, times dv dx, which is 10x, all over v squared, which is 5x squared minus 2 all squared. And so if we tidy up and factorise, we have minus 3 times 5x squared. We've collected the x squared terms together. Minus 3 times 2, as shown here. All over the denominator, which remains the same. And so we have our expression for dy dx. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to find the stationary point of the curve C with equation y equals e to the power 2x plus 3 over x, where x does not equal 0. We're going to let u equal e to the power 2x plus 3 and v equal x. This is of course so that we can apply the quotient rule. And so we have du dx equals 2e to the power 2x plus 3 and dv dx equals 1. We can now plug these expressions into the quotient rule. So we have dy dx equals v, which is x, times du dx, which is 2e to the power 2x plus 3, minus u, which is e to the power 2x plus 3, times dv dx, which is 1, all over v squared, which is x squared. And tidying up and factorising gives us e to the power 2x plus 3 times 2x minus 1 all over x squared. Remember that we are required to find the stationary point, and at the stationary point dy dx is equal to 0. When dy dx equals 0, we have e to the power 2x plus 3 times 2x minus 1 all over x squared equal to 0. This of course implies that 2x minus 1 is equal to 0. Which implies x equals 0.5. At x equals 0.5, we can plug in x equals 0.5 into the formula for y to give us this expression shown here. Tidying up gives us 1 over 0.5 is 2. E remains of course as it is. And this is raised to the power 4, as shown here. So therefore the stationary point occurs at 0.5, 2 e to the power 4. This brings us to the end of this session. If you have understood its contents, you should be able to differentiate functions using the quotient rule. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.